Hello everybody. So there's hundreds of videos out there that'll show you how to blink a single LED on and off. Pretty simple, pretty basic, pretty boring. So that's not what we're going to do here. If you do want to do that, you can go to the Arduino IDE, go up to the File menu, go down to Examples, and over to the Basic Examples, and choose the Blink sketch. That'll show you everything you need to do, and you can upload that to your Arduino and play around with it. So in this video we're going to do something a little more interesting and a little more fun. We're going to do three different versions of the sketch. So in the first version we're going to take a red and a blue LED and we're going to make them look like old police cars where they blink back and forth continuously. Then in the second version of the sketch we're going to make it look more like a modern police car where it blinks back and forth slowly, but then it changes speed and goes really fast, then it slows down again. They kind of change it up a little bit to draw your attention. Then in the third and final version of this, we're going to focus more on the sketch itself. We're going to make it a lot more efficient. So in the second version, we had more of a beginner's mindset where we're doing whatever it takes just to get it to work. But in this third version, we're going to go back and rewrite it so that it's easier to make changes and adjustments later on. It's going to take up much less of the microcontroller's memory, and it's going to be much shorter as far as how many lines of code it takes to make it. Hello, I'm Sean and welcome to my shop. I'm a dad that likes to make all kinds of things for my hobbies, and I usually end up learning a lot of things along the way. I like to tinker with electronics, Arduinos, Raspberry Pis, that sort of thing. I also do 3D printing, some laser engraving. I like to do a little woodworking, and I love model railroading. So if you share any of these hobbies with me, make sure to hit that subscribe button. This is a brand new channel, but there's a lot more videos coming out. Let's get started. Alright, the first thing we need to do is build our circuit. So we have a nice clean breadboard here with our Arduino Uno, just waiting for some wires and some LEDs. So if you're not familiar with wiring up LEDs or how a breadboard works, I'm going to put a couple links down below so you can watch those videos. Just take a few minutes, watch those videos, and then come on back to this one. I'm going to put a schematic up on the screen so we can follow along on what we're wiring. I always like to start by bringing power from the Arduino over to our power rails. So in this particular case, we're actually not going to use our 5 volt. We're going to bring power from our digital pins, but I like to wire it up just in case. You never know what we might end up using it for. So I'm going to bring from our 5 volt and our ground over to the ground on the breadboard and our 5 volt. Those are ready to go. A couple digital pins, we need two, one for each LED, a red and a blue. Let's go ahead and use pins 3 and 4. So we're going to use pin 3 for our red LED. We'll go ahead and go to digital pin on the Arduino for that. And our blue LED, and you notice I'm just for clarity's sake, I'm using a red and a blue wire. So the blue wire will go from pin 4, and we'll just put that in here. Red wire from pin 3, we'll put that right there. And now we've got to wire up our LEDs. So we're going to go to the positive side of our red LED, right there, and then the positive or the anode side of our blue LED, going from the blue pin on the Arduino over. Then we just need a couple of 330 ohm resistors. So let me get this wire out of the way, it's kind of right in the view. Okay, so I've got a couple 330 ohm resistors. You can use like a 220, anywhere between 220 and 330 is fine. I like to use 330 as a good starting point. So we're going to go from our negative pin of the LED to our negative pin or ground on the power rail. There we go. And we're going to do the same thing with our red LED. We're going to go from the negative side of the LED to our ground. Whoop. I've kind of got the legs cut pretty short on this one. Going to our ground on the power rail. There we go. Okay, So now that should do it, but let's just double check. So we're coming from pin 3 of the Arduino over to the positive leg of the LED, red LED. From the negative pin of the red LED, we're going to go through the 330 ohm resistor and then to the negative, which will flow back through this jumper, through the negative, into our ground on the Arduino. We're going to do the same thing with our pin 4, digital output pin 4. That's going to power up our blue LED, so it's coming over here to our positive side of the blue LED, negative side of the blue LED, going through the resistor, 330 ohm resistor, to the negative or ground on the rail, and over to our ground to the Arduino. So that should do it. We are all set. We've got it wired up. We've double checked everything. We are ready to go create the sketch. Couple things we need to do to start with. We need to save the work. So let's go up to File menu, down to Save As. Pick a good spot on your computer to save it. I've got a folder here already set up for Police Blink, so I'm going to save it in there. I will call it Police Blink, and I like to use a date so that I know what version or when I created it. So it is 2026 05 08, and that'll get it saved for us. Next thing we need to do is we need to tell it what COM port our Arduino is on. Come down here to the hourglass, and your computer may be different. It depends on what version of Windows or Mac you're using, but we're basically looking for the device manager. So if you type a search for device manager and go to that, then when that comes up, you're going to want to go to ports. And in my case here, I can see that I'm on the Arduino Uno is on COM5. So if I come back here, it should say, yep, Arduino Uno COM5, so I want to choose that one. One thing that I'm in the habit of doing when I write a new program or a sketch of any kind, I go ahead and document what it's for, when I created it, that type of thing. So I'm going to go ahead and do that now. I'm going to start with a few comments. We start a comment with 2 slashes, and then I will go ahead and fill in some of this information, and then we'll continue on. Next thing we're going to do, we need to add a couple of constant variables. So if you're not familiar with variables, a normal variable we are going to use in our program that may change the value as we're running the program. We're going to use some constant variables that are going to stay always the same number. So in this case, we're going to set up a constant variable for, this is going to be a type byte. And I will explain here in a minute what that will do, but we're going to set this up to read the Arduino pin number 3. So for our red LED pin, we're going to use number 3, and we're going to set one more up for also type byte. I'll put a chart up on the screen here, but basically we're using a type byte because that'll give us we can use between 0 and 255, and it uses the least amount of memory in the microcontroller. So a lot of times people go straight to using an int, but that actually uses, I believe it's like 32,000. So this one here, we're going to use the blue LED pin. We're going to put that one on pin 4. And then we want one more constant. This one we are going to use an int, and this is going to be for the speed that we're going to blink. I'm going to call this slow blink. And we're going to set this up for 750 milliseconds, or 3/4 of a second. That'll be the speed that we blink and hold one on before it switches to the other. Okay. We can go ahead and get rid of this code here. This just tells us that this is where we, in the setup function, is where we set everything up. This code in this function runs one time when we first start up the Arduino, and then once it gets into the loop here, it'll loop through this constantly. So it'll just keep looping any code that we put in this function. So to start with, in the setup function, we're going to have to tell it these pins that we're setting up for the red and the blue LED. We need to tell it whether those are going to be inputs or outputs. So we're going to use, and then we'll set one up the same way for the blue pin. And the next thing I like to do is anytime I'm using sensor or LEDs or anything like that, I always like to, in the setup function, I will set the state. Like for an LED, we want it to start in the off state. So I'm going to go ahead and do a digital write and write low to both of those LEDs so that they start out being off. And we'll do the same thing for the blue. Okay, that should give us everything we need in the setup. So we're basically starting out, we're telling it that both the red LED pin and the blue LED pin on the Arduino are going to be set for outputs. And we are going to write the initial state of both of those as low or off. So now we can go over to the code for the loop, which will continuously loop the whole time that the Arduino is running. And what we're going to want to do here is do a digital write and turn the red on and the blue off. Once we've turned the red on and the blue off, we're going to put a delay in here so that it pauses for just a second for that slow blink amount. So we're going to say delay. Slow blink. So by doing it this way, what happens is every time it goes to this line of code, it's going to put a delay in for slow blink. Well, slow blink is equal to that 750 milliseconds. So if we ever want to adjust that, every time we've written this line of code in the program, we only have to change it one time up on top where the constant is, and it'll automatically adjust all the way through the program. Okay. So next thing we're going to do is pretty much the same thing, but in reverse. So we're going to turn the blue on and the red off. And that should do it for our program. The only other thing, I'm going to go in here and write some comments in here so that we know exactly what each line is doing. It's just a good practice to keep track of that as our programs get bigger. Okay, that should do it. Now we're going to want to go up and save our work again, obviously, just so that we don't lose anything. And then we're going to want to hit the check mark up here, which is going to verify our sketch and make sure we don't have any errors in it. And it looks like this is error-free and ready to go. So right now our sketch is going to use 988 bytes, or 3% of our program storage on the microcontroller. We're all set. We're ready to send it over to the Arduino by clicking this upload button. And then let's go check it out and see what it does. Alright, so we're back in the shop. Unfortunately, my Arduino, where I write my programs and my sketches, is actually upstairs. So I run up there, I go ahead and write the sketch and upload it to the Arduino, and then I bring it back down to my shop and I plug in the power. So that's where we're at right now. We're all wired up, ready to go. I'm going to plug in the power and let's see what the sketch does. This is the first version. And sure enough, we are blinking back and forth between the red and the blue lights like the old police cars used to do. And the time that it is going between the red stays on for that 750 milliseconds, and then it switches over to the blue for the 750 milliseconds. So this is working great. So let's go ahead and head back up to the computer, and we'll write the second version where we're going to speed these up and make it look more like modern police lights. Okay, so now we've seen the version 1 and of the old police lights and how we can make it blink back and forth between red and blue. Kind of slow. Now we're going to work on a second version that is going to look more like modern day police lights. So it's going to blink back and forth really slow like we did before. We're going to do that about, let's say, 5 times. And then we're going to blink really fast. Let's make it do 15 times. And then in the loop, we're going to just keep doing that. So it's going to blink 5 times slow, 15 times fast. So what I'm going to do is just go ahead and do like any beginner would. And we're just going to write this code to make it work. We're not too worried about efficiency. We're going to worry about that on the next version. So right now, we've already got it to where it turns the the red on and the blue off, then it waits, then it turns the red off and the blue on, and it waits. Well, that's exactly what we want to do, but 4 more times. So I'm going to put in here just a little note that says this is slow blink 1. That way we can keep track of it and not do too many of them. So we're going to do, I'm just going to cut and paste it. So this is going to be slow blink 2, 3, 4, 5. So before I forget, let me add this up here, version 2. Okay, so now we are going to slow blink 1 times, 2, 3, 4, 5 times. Now we're going to want to do a fast blink, so we're going to create another constant variable up here. And let's make this, let's say 150 milliseconds. So basically we're going to do the same thing, but we're going to change that slow blink to a fast blink. So if you haven't noticed by now, I like to cut and paste. I'm a slow typer, so I like to take advantage of cut and paste as much as I can. Alright, so right now we are slow blinking 5 times, and we have a fast blink set up once. We're going to do that 15 times total, so we're just going to cut and paste that. That'll be the second, third, fourth. Okay, so as you can see, our program has gotten really long, but it should work. We're going to slow blink 1 time, basically 5 times, and then we're going to kick over and we're going to do the same thing, but we're going to be blinking a lot faster because we have changed our constant variable of fast blink down to 150 milliseconds. Let's even make that 100 milliseconds. I want to see it go pretty fast. So we'll see in our next version how this can affect us. Right now we have 165 lines of code just to make this work. And this is a pretty simple sketch. So let's go ahead and verify it and make sure we don't have any errors. We do not. So our sketch is using 2062 bytes, or 6% of our program storage on the microcontroller. We're not really, this is a simple enough sketch, we're not really going to see an impact on the microcontroller running slower or anything like that. But if this was a really large program, we might. So that's where it can come into play on writing more efficient code. So let's go ahead and upload this to the Arduino and let's see what it does. Alright, we're back in the shop with our second version. So this one should be blinking slowly for 5 times and then fast for 15 times. Let's go ahead and plug it in and see what we got. That seems to be working good. 5 slow blinks and then back and forth for 15 times. Actually, I think we should have done 10. But that's where that efficiency of our code and the way we wrote it, it's going to be kind of a pain to go back and change from 15 fast blinks down to 10. So let's go ahead and rewrite the code one more time. Let's make it a lot more efficient and easier to make any kind of adjustments like that. Okay, so we're ready to go ahead and make our third and final version of this sketch. This should finish it up, and we're going to make this a lot more efficient. And it's also, with it being more efficient, it's going to make a lot easier to make any kind of changes we want to do. So first thing we're going to do, well, first thing we're going to change this to version 3. So if you notice the code when we're writing it, a lot of it, it's doing the same thing over and over and over. It's just over redundant. So what we want to do is basically make a loop like this is. And this loop is a program loop that it's going to keep doing the same thing, both the slow section and the fast section over and over. But if we just break it down to the slow section first, it's doing the same thing 5 times. So we can create a for loop that is going to, basically it's going to loop 5 times, and we'll put the same code in it. So we're going to do a slow blink for loop. We're going to create a variable in the for loop. So we're going to say for, and the variable type is going to be an int. We probably could do byte, but I guess for some reason I'll have to look into that. I've never used a byte in a for loop, but it might be possible. I've always done int. So we're going to create an integer, and we're going to say the variable name is going to be x. So x is going to be equal to 1 to start with. So we're initializing our integer x to 1. Next, we're going to say how many times we want to loop. So in this particular case, we want to continuously loop until x is less than or equal to 5. So as long as x is less than or equal to 5, we'll go ahead and keep doing this loop. All right, the next thing we need to do is put in x plus plus. That's basically going to make it increment x by 1. It's kind of the same thing as putting x is equal to x plus 1. So every time it comes back up, it's going to increment x by 1, and then it'll go through the loop and make the decision of whether or not we run the loop again or if we kick out. So we're going to do the same code. We're still doing the same thing. We're just doing a for loop that's going to do it 5 times for us now. Okay? And by doing so, all of this other code for the slow blink, we don't need it anymore. That one for loop is doing all of it. Okay? So what's going to happen is when we load up the Arduino, we put power to it, it's going to run through the setup, then it's going to go into its own loop function. In the loop function, it's going to start our for loop, which is going to create a variable x, and it's going to make a decision, does it need to run through the for loop. In this case, x, which is equal to 1, is less than 5, so it's going to go ahead and run through the loop here. It's going to do this code. It's going to blink the red on, blue off, red off, blue on, and then it's going to come back up here and increment before it starts and evaluates it again. So now x would be, what did I just say? We did 2, so it would be 3 this time, and it's still less than 5, so it would do it again, increment, it'd be 4, it'd come up here, do it again. When it gets to 5, it comes up here and looks and says, oh, it's now equal to 5, so we're not going to do with this for loop. It's just going to jump out and continue on with the program down here. So that's perfect for the slow loop. Now we can basically do the same exact thing, but for the fast loop. So as a matter of fact, I'm going to make it easy on myself and just copy and paste. Change this to, it is now the fast loop. And we are going to change this stuff here. Actually, the coding, I would have been better just to take the fast loop here. My comments change and everything too, so we'll go ahead and do that. Okay. And I want to get the proper indentations here. Just makes it a lot easier to read our code later. Now this one we wanted to do 15 times, so we're just going to put a 15 in there. So same thing. Matter of fact, we could even change this instead of it still being x, since we're using x here. Let's do a slow x. So sx is our variable. sx, sx. This will be fx for fast loop. Okay. So the slow will run through this 5 times. It'll come down here. It'll run fast through this 15 times. And because we've done that up here, all of this fast blinking that we did, that can all be taken out. So we have basically gone from 160, I don't remember what it was, let's say 165 roughly lines of code. We've got it down to like 42 now. So a lot more efficient. The other thing is we can also make changes up here with our constants. I want to, for instance, take our slow blink. I think it was actually a little too slow, so I'm going to change that to 500. And let's change this to 75, so it's going to move a lot faster. And I think we're done. So this should effectively do the same thing other than go a little bit faster now. Let's go ahead and check it, make sure we don't have any errors, and we don't. So take a look at that. Before we were like 2,262, I believe. Now we're 1,072, so we are definitely using less memory on our microcontroller than we were before. So this code is definitely a lot more efficient, cleaner, easier to read, and a lot easier to manipulate and make any changes later. Go ahead and get it uploaded, and we'll go check it out. All right, we're back in the shop for the third and final version. I say final, but I think I might want to make one more correction. So when we were writing the code, I ended up changing that for loop back to doing it 15 times. I might go ahead and adjust that to 10 and play around with some speeds, but those are all little adjustments that are easy to make now. Let's go ahead and plug it in and see what it does. So we're blinking back and forth 5 times. Should pretty much work the same as it did last time. Our blinking back and forth in fast loop, although we're doing it 15 times, it is a little bit faster because we changed from 100 milliseconds. I think we went down to 75 milliseconds. So sure enough, yeah, I like that. So go ahead and play around with the how many times you want to slow blink, how many times you want to fast blink. You can change those numbers in your for loops. You can change the speed in our constant variables up on top of the program or the sketch, and save it, upload it to the Arduino, play around with it. That's how we learn. So if you've enjoyed this video and you learned anything from it, hit that subscribe button. There's a lot more videos coming out. Leave some comments. If you can think of other ideas or how we could make things better, let me know. I'd love to hear from you guys, and I love learning just as much. Take care. Thanks for watching.